Good morning, all. Mark your attendance, write your name and seat number in the chat box. Uh, Yesterday we started this chapter, Structure of Atom. It is one of the biggest chapter in physical chemistry, the 7 marks weightage. Actually, the basic information already you studied in the school level. What is meant by atom? And most of the part it is deleted from this chapter. That is discovery of electron, discovery of proton, discovery of neutron. That is how cathode rays are prepared, how canal rays are prepared, their properties. All this part is deleted, introduction part is deleted because it is assumed by the members. This part you already studied in your school days. That's why the advanced part only it is kept for your study. So yesterday we studied the Bohr's atomic model. This Bohr's atomic model is only related to the hydrogen atom, who studied the hydrogen spectrum and explained his model. But there are some drawbacks of this Bohr's theory. I think also we discussed about these drawbacks yesterday. Again, I will explain in 2 minutes. So this Bohr's model fails to explain atomic spectra of the elements containing more than one electron. So this is a restriction given by the Bohr, who studied the spectrum only for hydrogen atom, and hydrogen contains only one electron. So this spectrum or this model is only related to the elements which contain only one electron. For the other electron, what will happen? This is not explained by the Bohr. So this is main drawback. Then second drawback or second limitation is when hydrogen spectrum is observed using spectrometer of high resolving power. High resolving power means whatever the spectrum observed by the Bohr, when this spectrum is observed under a microscope whose resolving power is very high, means when the spectrum is zoomed, it is observed that the individual lines are not single. Means whatever the lines observed by the Bohr is not single line, but there are some lines. This is called as hyperfine spectrum. ये single lines किसके? This is not explained by the Bohr. These lines contains what, or what is the meaning of these hyperfine spectrum? This is not explained by this scientist Bohr. Then third limitation or third drawback is this model fails to explain splitting of atomic spectral lines. Splitting means it is separation of spectral lines. When the magnetic field is applied, the spectral lines are splitted, and when the electric field is applied, also there is a splitting of spectral lines. This is studied by the two different scientists who are the colleagues of Bohr. बोर के नीचे ये काम करते थे. The name of the scientists are Zeeman and Stark. So Zeeman studied the magnetic field. When the magnetic field is applied, there is a splitting of spectral lines, and when the electric field is applied, this experiment was done by this scientist Stark. So there is also the splitting of spectral lines, but why this is happening, this is not explained by this Bohr. And the last one drawback is Bohr's model or Bohr's theory, it is failed to explain the ability of the atoms to form molecules by chemical bonds. How the molecules are formed by the chemical bonds, this is also not explained by the Bohr. So after Bohr, why this model fails? There are mainly two reasons. So in this new point, for the failure, reasons for failure of the Bohr's model. Why there is a failure? Because after Bohr's model, there is a development of two main things. That two main things are de Broglie, it is again the name of the scientist, de Broglie proposed dual behavior of matter. According to this scientist de Broglie का ऐसा ओपिनियन था कि मैटर एग्जिस्ट इन ड्यूअल बिहेवियर, मीन्स इट आल्सो एग्जिस्ट इन अ वेव नेचर एंड आल्सो हैविंग द पार्टिकल नेचर. These 2 points de Broglie proposed dual behavior of matter after this Bohr's model. When Bohr proposed his model, after his model, these developments are coming out, and because of these developments, Bohr's model is again failed. The second reason is Heisenberg uncertainty principle. So, in detail, we will discuss what is the de Broglie's opinion about the matter. So, de Broglie is one of the scientists who studied many experiments and who given his opinion. So what is first we will discuss बोर का क्या, बोर्स मॉडल में बोर ने क्या एक्सप्लेन किया है. देखो, इन बोर्स मॉडल बोर एक्सप्लेन द इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड द स्पेसिफिक कॉन्सेंट्रिक पाथ. मीन्स electrons are revolving around the specific concentric path above around the nucleus. This is the result given by the Niels Bohr. And what is this opinion of the de Broglie we will discuss here. In contrast, de Broglie's opinion, de Broglie's proposed his theory in 1924. This is regarding the matter. And according to de Broglie, matter exists in dual behavior. Matter behaves as a wave particle. It is behave as a wave and it also behaves as a particle. So this is the opinion of the de Broglie. Both particle and wave-like properties, means matter having these two properties. Sometimes it behaves as a particle and sometimes it behaves like a wave. So momentum, this is a property of the particle, and wavelength, this is a property of the wave. So each matter having these two properties or two behaviors, this is explained by the scientist de Broglie. De Broglie का ऐसा opinion है कि matter having the both the properties, it is also having the wave property, it is also having the particle property. So the relation is given by this de Broglie. Lambda is equal to h divided by mv. Mv is nothing but this is momentum. So lambda is equal to h divided by p. De Broglie's prediction, later it is confirmed by the experiment. Diffraction experiments confirm it is a matter having the wave property. So this is the de Broglie's explanation. And what is Heisenberg uncertainty principle? Again, this Heisenberg, it is the name of the scientist. In the year 1927, Werner Heisenberg stated his uncertainty principle. What is this principle? See, it is impossible to determine simultaneously the exact position and exact momentum of an electron. Means we cannot determine at a time the position and the velocity of the electron. But in other words, a position and momentum of the electron cannot be determined with the same certainty. Means at the same time we cannot determine these two properties, position and momentum we cannot find. But बोर का क्या रिजल्ट देखो, बोर्स मॉडल में बोर्स ने क्या बोला है. Bohr's model assumes that both position and momentum of the electron in hydrogen atom are known exactly. So this is the main failure of the Bohr's theory. Bohr का क्या, according to Bohr's का suggestion और Bohr's का opinion और Bohr's का result क्या था, देखो इधर Bohr ने क्या बोला है कि we can find position and momentum at a time. But Heisenberg क्या बोलता है कि it is not possible to determine simultaneously the position and momentum. We cannot find. So this is a main failure of this Bohr's theory. Yes, Chaitanya. Chaitanya Vaidya, tell me, huh? You raise your hands. Chaitanya, any doubt? Unmute yourself and tell me.
येस सर.
Tell me.
सर ती अनसर्टनिटी का बरं जनरेट होते सर पण म्हणजे
त्यांनी वेगवेगळे
जेव्हा
एक्सपेरिमेंट केले. हायसेनबर्गने वेगवेगळे एक्सपेरिमेंट केले आणि सांगितले की एका वेळेस आपण इलेक्ट्रॉनची पोझिशन आणि मोमेंटम फाइंड आउट करू शकत नाही. पण बोर काय म्हणत होता की एकाच वेळेस आपण त्याची पोझिशन आणि मोमेंटम दाखवू शकतो. तर हे कुठंतरी कॉन्ट्रडिक्शन आहे, कारण हे जे एक्सपेरिमेंट हायसेनबर्गने कधी केलेले बघा 1927 मध्ये, आणि बोरचं मॉडेल त्यांनी कधी सांगितले 1913 मध्ये. मला वाटतं 1913. येस, 1913 मध्ये. येस, सी दिस नील्स बोर 1913. मग त्याच्यानंतरचे जेवढ्या वर्ष एक्सपेरिमेंट केले किंवा आपलं जे काय म्हणतो आपण सायन्समध्ये डेव्हलपमेंट झाली, त्याच्यावरून त्यांनी सांगितले की असं आपण करू शकत नाही. वी कॅनॉट फाइंड एक्झॅक्ट पोझिशन अँड मोमेंटम. सो दिस इज एक्सप्लेन बाय दिस हायसेनबर्ग. याचं खूप मोठी वेव्ह मेकॅनिक्समध्ये, क्वांटम मेकॅनिक्समध्ये याचं तुम्हाला स्टडी करायला मिळेल. लॅटर ज्यावेळेस तुम्ही ग्रॅज्युएशन कराल, तुमचं पीजी कराल, त्यावेळेस तुम्हाला याची खूप इन्फॉर्मेशन मिळेल. याच्यावरती एक फिजिक्समध्ये पेपर आहे, वेव्ह मेकॅनिक्स आहे, क्वांटम मेकॅनिक्स आहे. डिटेलमध्ये तुम्ही जेवढं जाईल तेवढी तुम्हाला इन्फॉर्मेशन मिळेल. बट फॉर दिस 11th स्टँडर्ड, रिमेंबर, there is uncertainty. We cannot find the position and exact momentum of the electron. Then later quantum mechanics model developed a new branch of science. It is called as quantum mechanics. See, this is developed in 1926 by this scientist, again Heisenberg and Schrodinger. These are the again two scientists, Heisenberg and Schrodinger, based on the uncertainty principle and wave motion respectively. ये दोनों ने क्वांटम मैकेनिक्स के ऊपर बहुत काम किया है. सो क्वांटम मैकेनिक्स इज बेस्ड ऑन द आइडियाज ऑफ वेव मोशन. It will be discussed here. So this Schrodinger equation is a very long equation. In the 11th standard it is not given, but only the functions are given here. So the Schrodinger equation, or it is also called as the wave equation, is given. See, this is H, it is Hamiltonian. It is called as Hamiltonian, and this is the psi. This is Hamiltonian and this is the psi. This is energy and again it is the psi. So it is explained here. Here H के ऊपर ऐसा जो symbol है ना, this is called as Hamiltonian. This is Hamiltonian. It is a mathematical operator, and this psi, this is psi. It is a wave function. So this psi is a wave function, and this is a mathematical operator. E is the total energy of the system. So solving this Schrodinger equation, it is not expected for the 11th standard. It is for the MSc level. The Schrodinger equation is given. So only for the introduction purpose, this Schrodinger equation is it is introduced in the 11th standard. What is the use of this Schrodinger equation? So according to this, by using this Schrodinger equation, these quantum numbers we can introduce. There are mainly 4 quantum numbers, and what is the role of these quantum numbers? So exact what is the position of the electron around the nucleus, where exact the electron is present around the nucleus, in which subshell it is present, in which in which shell, in which subshell, in which orbital, what is the orientation of this orbital, where it is present in px orbital or py orbital, or it is in pz orbital or d orbital. So what is the main function of these quantum numbers? These quantum numbers are developed by these two scientists actually, Heisenberg and Schrodinger. And what is the main purpose of these quantum numbers? To know the exact position of the electrons, where the exact electrons are kept around the nucleus. Rutherford also got failure to know to denote the exact position of the electron. Bohr's model also failed to denote vac. बोर का कहना था कि electrons are revolving around the nucleus, but when these quantum numbers are developed, we got the clear-cut idea where the electrons are kept exactly, in the which shell it is kept, then in which subshell it is kept, then in which orbital it is kept, and what is the orientation of this orbital, whether it is along with the x-axis or whether it is along the y-axis or whether it is z-axis. So by studying these quantum numbers, different quantum numbers, we will get the idea of the electrons, where the electrons are kept around the nucleus. So one by one, we will discuss these quantum numbers. There are mainly 4 quantum numbers. So this is very important for the examination point of view. Many times the short notes are asked on this principal quantum number. It is denoted with the small n. इथं small m पाहिजे बरं का, माझ्याकडनं चुकून n झाले इथे. This azimuthal quantum number, it is also called as इथलं पण n राहिले. ठीक आहे, करेक्शन करतो मी लगेच, एक मिनिट. So the definition of quantum number is mentioned here. The numbers which identify the state of electron. Also, they specifies the energy associated with it and its location around the nucleus. It is called as quantum numbers. Mainly, there are 4 quantum numbers. First one is principal quantum number. It is denoted with small n. Then azimuthal quantum number. It is also called as angular momentum quantum number. It is denoted with small l. Magnetic quantum number, it is denoted with small m, and the spin quantum number, it is denoted with small s. Here one diagram is shown. This is the shape of s orbital. This is the shape of p orbital actually. This particular image is shown to denote the functions of different quantum numbers. So this principal quantum number actually, it denotes the distance from the nucleus, distance of the electron from the nucleus. Then angular quantum number or azimuthal quantum number denotes the shape of the orbital. Then magnetic quantum number indicates its orientation in space, and spin quantum number gives information about the spin of electron, whether it is in upward direction or whether it is in downward direction, how it is rotating, clockwise or anti-clockwise. So to understand a brief idea about the quantum numbers, this slide is shown. Detailed information of these quantum numbers we will discuss. First one is principal quantum number. If it is asked for 2 marks, only we have to write these information. Also, we can draw this table. So, before this, many times we discuss about this principal quantum number. This denotes actually the energy levels, main shells, and the main shells are denoted with this symbol K, L, M, N. This is given by the scientist Niels Bohr. So K, for K, N is equal to 1, for L, N is equal to 2, and the energy levels are increasing like 1, 2, 3, 4, 5, 6. So this principal quantum number denotes in which shell, that is main shell, electron belongs. It is also the distance of the electron from the nucleus. As we go away from the nucleus, the energy levels will increasing. We know this diagram. Again, I will show this diagram. Suppose this is the nucleus. This is the nucleus. So if the first shell, if the electron is in the first shell, so it is first energy level. Then it is the second shell, it is second energy level. Then it is a third energy level. Like this, energy levels will be increasing. So this will be the K, L, M, and N. Like this, the shells are increasing. So these are the main energy levels, and this principal quantum number is denoted with this number N. N is equal to 1 indicates first energy level. N is equal to 2 indicates the second energy level, like this. energy levels are also increasing, the distance is also increasing. Then allowed number of orbitals, it is given by the formula n square. Allowed number of orbitals, it is given here. See, principal quantum number, if it, these are the values, these are the shells. Allowed number of orbitals. In the first shell, only one orbital is there. We know only one s orbital is there. In the second shell, the formula, four orbitals are there. Anyone can tell me which four orbitals are there? I will unmute. Yes, anyone can tell me which four orbitals are there in the second shell? Anyone? According to this formula n square, these are the allowed number of orbitals. In the first shell, there is only one orbital, s orbital. In the second shell, tell me the orbitals.
4.
कुठले फोर ते सांगायचे मला नाव. Tell me the names.
P.
2s आणि 2p. बरोबर आहे. 2p चे किती झाले? हे px py pz 3 झाले आणि हे एक 4. ठीक आहे, कळलं का? आता p चे ऑर्बिटल असतात ना, परत px असतो, p चे ऑर्बिटल 3 असतात. दॅट इज px, त्याच्यानंतर py आणि pz. हे किती झाले? These are the three orbitals. p चे 3 ऑर्बिटल झाले आणि s चा एक, तो 3 + 1 4. Then in the third shell there are 9 orbitals. आता 3 चे orbitals काढू आपण. 3s, then 3p and 3d. आता 3s चा किती? एकच, s चा एकच ऑर्बिटल असतो. p चे परत 3 झाले. ठीक आहे, px py pz. आणि d चे 5 ऑर्बिटल असतात. हे कुठले ऑर्बिटल असतात ते आता तुम्हाला नंतर काढता येईल. 5 + 3 किती झाले? 8 आणि 8 + 1 9. सो 9 ऑर्बिटल्स. त्याच्यानंतर फोर्थ शेल मध्ये 16 ऑर्बिटल्स. आता त्याच्यामध्ये 4s 4p 4d आणि 4f. त्याच्यामध्ये +7 ऍड करायच्या मध्ये. हा, कारण त्याच्यामध्ये f चे 7 म्हणजे किती झाले? 9 + 7 झाले का? 16 बरोबर.
हो सर.
हा, आता ते हे एफ ऑर्बिटलचे शेप्स आणि हे ऑर्बिटल कसे असतात ते आपण वेगवेगळ्या क्वांटम नंबरचं काम आहे. इट इज द फंक्शन ऑफ डिफरंट क्वांटम नंबर्स. द प्रिन्सिपल क्वांटम नंबरचं काम मला वाटतं कळायला असेल. व्हॉट इज द मेन फंक्शन ऑफ प्रिन्सिपल क्वांटम नंबर? इट डिनोट्स द shell or main energy level in which electron is present. This is the role of principal quantum number. Then second quantum number is azimuthal quantum number. It is denoted with small l. It is denoted with small l. Remember, this can be asked for the MCQ purpose. It is also called as secondary, subsidiary, orbital, angular momentum quantum number. इतने उसको नाम है. Secondary quantum number, subsidiary quantum number, orbital or angular quantum number. This is denoted with small l. This represents the subshell to which electrons are belongs. It defines also the shapes of the orbital occupied by the electron and angular momentum of the electron. It can have only positive values between 0 to n-1, where n is principal quantum number. This quantum numbers provides the following information. So following information I will explain. The subshell in which electron is present. The subshells are represented by these letters S, P, D, F. These are the subshells. Actually, these are the short forms. So the letter S, P, D, F indicates these are derived from the terms. For S, it is sharp. P, it is principal. D, it is diffused. And F for fundamental. These sharp, principal, diffuse, and fundamentals, these are the terms used in spectroscopy to describe the nature of spectral lines present in the emission of atom. So इसमें डिटेल्स में जाने की आपको जरूरत नहीं है. शार्प, प्रिंसिपल, then diffusion, diffused and fundamental, these are the terms which are used in spectroscopy. Now this table is very important because by using this table, uh, these values we have to remember. So this is the, for s orbital the value of L is 0. Then for p orbital it is having value 1. For d orbital it is having value 2, and for f orbital this is having value, so 0 1 2 3 SPDF. We have to remember like this. Then the second important role of this azimuthal quantum number is the number of subshell present in the given principal shell. Actually जितने main shells है उतने subshells present रहते हैं. Remember this. So if one shell is there, only one subshell is present. These are the main shells K, L, M, N. It is having the value 1, 2, 3, 4. These are the energy levels. This is the value of N, which indicates the principal quantum number. See the permissible value of L. This is for 1, it is 0. For 2, it is 0, 1. For third shell, it is 0, 1, 2. Fourth shell, it is 0, 1, 2, 3. So possible subcells here, it is written uh, for 0, it is yes. Now tell me the values. 0 किसके लिए S, 1 P, 0 1 2 SPD, 0 1 2 3 SPDF, and this is the total is given 1 2 3 4. So जितने shells है उतने subshells रहते हैं, remember. So if n is equal to 1, there is only one subshell. If n is equal to 2, there are two subshells. When n is equal to 3, there are three subshells. When n is equal to 4, there are four subshells. So remember these values. Then it also indicates the shape of the subshell. It also indicates the azimuthal quantum number or principal quantum number, also indicates the shape of the subshell. Means it is a orientation. Actually it shows the orientation, the spatial distribution of electron cloud around the nucleus. Later on we will understand. It also denotes the number of electrons present in the subshell. For this we have to use this formula. For this we have to use this formula, 2 into bracket 2L plus 1. By using this formula you can calculate the number of electrons in the subshell. Actually you know the capacity of S is 2 electrons, the capacity of P is 6 electrons, the capacity of D is 10 electrons, and the capacity of F is 14 electrons. So we will discuss, I will explain with one for the s orbital how these two electrons will come. 2 into bracket C, 2 into bracket 2 L plus 1, 2L plus 1. Now tell me for this S subshell, what is the value of L? What is the value of
0.
0? So
0.
2 into 0, it will be 0. 0 plus 1 is 1. So 2 into 1, it will be 1. So put here for p orbital, what is the value? It will be 1. So 2 into 1, it will be 2. 2 plus 1 is 3. 3 into 2, 6. So 6 electrons. असं तुम्ही जर काढले तर हे तुम्हाला व्हॅल्यूज मिळतील. हे ऍक्च्युली तुम्हाला मी याच्यामध्ये सांगितलंय त्या पिरियडिक टेबलमध्ये. त्याच्यामुळे हा कॉन्सेप्ट तुमचा क्लिअर झाला असेल. 1s2. 1s2 लिहायचं म्हणजे आपण का लिहायचं 1s2? कारण एसची कॅपॅसिटी 2 इलेक्ट्रॉनची. त्याच्यानंतर 2s2. इथे 2s2 का लिहायचो? कारण एसची कॅपॅसिटी 2 आहे. आता तुम्हाला इथे हा कॉन्सेप्ट क्लिअर होईल की फर्स्ट शेल मध्ये एकच सबशेल आहे, सेकंड शेल मध्ये 2 आहेत, एस आणि पी. थर्ड मध्ये 3s, 3p आणि 3d. हा, पण भरताना आपण कसं करतो, 1s 2s झाल्यानंतर 3s 3p, 3p नंतर इलेक्ट्रॉन 4s मध्ये जातो. दिस इज गिवन बाय द अबोव प्रिन्सिपल. आणि 4s भरल्यानंतर मग 3d मध्ये जातो. पण लक्षात ठेवायचं आहे की 3चे ऑर्बिटल किती आहेत? फोर्थ शेल, इफ द इलेक्ट्रॉन एंटर्स इन द फोर्थ शेल, त्याचे 4 शेल भरले पाहिजेत, म्हणजे SPDF हे भरलंच पाहिजे. त्याच्यानंतर इलेक्ट्रॉन परत 5व्या शेल मध्ये जातो, तिथं 5 सबशेल आहेत, म्हणजे SPDF आणि परत S मध्ये इलेक्ट्रॉन जातो. ठीक आहे. हा, आता मॅग्नेटिक क्वांटम नंबरचं काम काय सांगतो. व्हॉट इज दिस मॅग्नेटिक क्वांटम नंबर? This quantum number is used to explain Zeeman effect. So this Zeeman, हाँ साइंटिस्ट है जीमन, इट इज द नेम ऑफ द साइंटिस्ट हु इज असिस्टेंट ऑफ बोर. उसने मैग्नेटिक फील्ड के ऊपर बहुत काम किया है. So this quantum number is used to explain Zeeman effect. It is represented with the letter small m. Principal quantum number, it is denoted with small n. Azimuthal quantum number, it is denoted with small l. Magnetic quantum number, it is denoted with small m. And the spin quantum number, it is denoted with small s. Remember this letter small m. It is having the values of m are governed by the values of l. If you know the value of l, we can find out the value of m. So it is having the values minus L2 plus L through 0. I will explain with this example. The magnetic quantum number m gives us information about the relative spatial orientation about the orbitals. Means actually it shows in which orbital electron is present. Principal quantum number क्या करता है कि in which shell it is electron is present. Azimuthal quantum number indicates in which subshell electron is present. This magnetic quantum number denotes in which orbital, means whether it is present in px, py, or pz. It shows exact orbital, and spin quantum number denotes how the electron is spinning. So here the values are given for S subshell. Now you are familiar with this value. For S subshell, L is equal to 0. So therefore M will be 0 again. So it is, there is only one orbital. For P subshell, I will explain here. For P subshell, you know the value of L is plus 1. 1 means it is actually plus 1. So the value of M will be, what is this relation is given? Minus L to plus L through 0. So I am writing the values of here. For p orbital, the value of L is plus 1. So it will be plus 1, 0, and minus 1. So किती व्हॅल्यूज झाल्या टोटल याच्या? 3 झाले ना त्याचं. 1 2 3 म्हणजे याच्यामध्ये 3 ऑर्बिटल असतील, लक्षात घ्या. पी सबशेल साठी साठी किती झाले? 3 ऑर्बिटल. मग हे 3 ऑर्बिटल कुठले त्याची इथे दिलेली का? इट इज डिनोटेड विथ px, py, pz, where x, y, z, these are the coordinate axes. So the p orbital possesses the different orientation in space. Px, it is oriented along the x-axis. Py along the y-axis. Pz along the z-axis. In absence of magnetic field, if the magnetic field is not there, all the 3 p orbitals having the equivalent energy, and it is known as threefold degenerate when the magnetic field is not there. But if the magnetic field is applied, they acquire different energies and their degeneracy is removed. So remember, degenerate orbitals means which is having the same energy if the magnetic field is not there. If the magnetic field is applied, their energies will be changed. Now this is for p orbital, p subshell. Now anyone can tell me what is the value for d subshell. Now for d subshell, tell me what is the value of L?
2.
2. Now tell me the values of magnetic quantum number. Plus 2, it is again plus 1, 0,
0.
comma करतोय मी इथे, 0, then
-1.
-1, correct, and
-2.
-2. Total किती झाले count करायची? 1 2 3 4 5.
5.
It is having 5 orbitals. 5 orbitals. आता ते कुठले कुठले ऑर्बिटल, डी साठी 5 ऑर्बिटल्स कुठलेत आपण बघू. It is given in this. See, for the d orbital, the value of L is 2. So the values will be plus 2, plus 1, 0, -1, and -2. तर त्याचे 5 d ऑर्बिटल d चे इथे दिलेले बघा. It is denoted with dxy, dyz, dzx, dx square minus y square, and dz square. These are the orbitals of डी सबशेल. आता त्याच्यामध्ये तीन बघा कशा असतात, डी एक्स वाय, डी वाय झेड अँड झी झेड एक्स. द ऑर्बिटल्स आर प्लेनर, एका प्लेनमध्ये असतात. त्याच्यानंतर हे डी एक्स स्क्वेअर वाय स्क्वेअर अँड डी झेड स्क्वेअर ऑर्बिटल्स आर ॲक्सियल ऑर्बिटल्स. आता त्याचा शेप ज्यावेळेस मी तुम्हाला दाखवेल, देन आय विल शो द शेप्स, देन यू विल अंडरस्टँड. दीज आर इन वन प्लेन. एक्स वाय, हाऊ टू रिमेंबर, एक्स अगोदर घ्यायचा, त्याच्यानंतर वाय, वाय अगोदर घ्यायचा, नंतर झेड, झेड म्हणजे पहिल्यांदा असं लिहून घ्यायचं डी एक्स डी वाय डी झेड. त्याच्यानंतर मग इथं वाय झेड आणि एक्स असं टाकून घ्यायचं. लक्षात घ्या, हे कसं लिहिण्याची सोपी पद्धत सांगितली बघा. कसं लिहायचं, डी एक्स अगोदर लिहायचं, डी वाय अगोदर लिहायचं आणि डी झेड एक्स वाय झेड असं लिहून घ्यायचं. ठीक आहे. आणि त्याच्यानंतर डी एक्स वाय, डी वाय झेड आणि झी झेड एक्स असं लिहून घ्या. मग तुमच्या ते लक्षात राहील, कन्फ्युजन होणार नाही. नाव फॉर एफ ऑर्बिटल द व्हॅल्यू ऑफ एल इज इक्वल टू 3. त्याच्या व्हॅल्यूज किती झाल्या, +3 +2 +1 0 -1 -2 -3. सो टोटल 7 values are there, 1 2 3 4 5 6 7. So 7 orbitals are there, 7, each orbital having the capacity 2 electrons. So याची capacity झाली 14 electrons, याची capacity झाली 10 electrons. त्याच्यानंतर P ची capacity किती झाली 6 electrons आणि S ची capacity झाली 2 electrons. लक्षात घ्या, ह्या कॅपॅसिटी आपण ह्या फॉर्म्युल्याने काढलेल्या आहेत. दॅट इज 2 into bracket twice L plus 1. By using this formula we can find out the capacity of electrons. त्याच्यानंतर शेवटचा क्वांटम नंबर सांगतो आणि मग थांबू आपण. ठीक आहे. स्पिन क्वांटम नंबर, इट्स इंडिकेट्स द स्पिन. This quantum number is represented by the small s. It shows the spin of electron, how the electron is spinning. As an electron can spin clockwise or anti-clockwise in two opposite directions, there are two values for this s. It is also always having the values +1, +1/2 and -1/2. आता हे मायनस चिन्ह इकडे गेले, लक्षात घ्या, -1/2. So it is also having the always having only two values, +1/2, plus when it is +1/2 it is upward direction, and when it is -1/2 it is downward direction. For clockwise the value is +1/2, for anti-clockwise it is having the value -1/2. So the spin of electron is denoted with
upward downward काय म्हणले,
arrows असतात. ते arrows म्हणजे upward ज्यावेळेस आपण असं arrow करतो ना, त्याची व्हॅल्यू असते +1/2, म्हणजे ते क्लॉकवाईज डायरेक्शनने असं फिरत असतं, असं असं लक्षात घ्या, असं. आणि अँटी क्लॉकवाईज म्हणजे ते असं उलट फिरतं. असे दोन स्पिन असतात इलेक्ट्रॉनचे, असं एक फिरत असतं आणि एक असं एक फिरत असतं. ज्यावेळेस आपण असे इलेक्ट्रॉन दाखवतो ना 1s2, आपण आता समजा 1s, आता जो पहिला इलेक्ट्रॉन असतो 1s1 म्हणजे हा कोणाचा, हायड्रोजनचा एकच इलेक्ट्रॉन आहे, तो क्लॉकवाईज फिरत असतो. त्याच्यानंतर 1s2 म्हणजे किती इलेक्ट्रॉन झाले, 2 इलेक्ट्रॉन झाले. हे 2 इलेक्ट्रॉन म्हणजे कोण झाला, हेलियम. हेलियम मध्ये एक इलेक्ट्रॉन असा असतो आणि एक इलेक्ट्रॉन असा फिरत असतो, एक क्लॉकवाईज एक अँटी क्लॉकवाईज, म्हणजे 2 इलेक्ट्रॉन झाले. आता तिसरा इलेक्ट्रॉन कुठे जाईल, 2s1 म्हणजे तो एलिमेंट बदलला, दॅट इज 2s1 म्हणजे तो झाला लिथियम. लिथियम मध्ये बघा A1s2 कंप्लीट झाला. आता 2s1 मधला इलेक्ट्रॉन परत तो क्लॉकवाईज डायरेक्शनने फिरतो, परत 2s2 परत अँटी क्लॉकवाईज डायरेक्शनला येतो. लक्षात घ्या. परत 2p. आता 2p मध्ये काय होतं की 2p चे 3 ऑर्बिटल येतात असे, एक px असतो, एक py असतो आणि एक pz असतो. बरोबर आहे, असं सांगतो मी. इकडे बघा, px, एकच मिनिट राहिले आपल्याकडे, px py pz. संपल्यानंतर परत जॉईन व्हा बरं का. हा, px मध्ये बघा इलेक्ट्रॉन असा जातो पहिल्यांदा क्लॉकवाईज, py मध्ये पण परत क्लॉकवाईज